In this lesson, we're going to go ahead and we're going to go over rectangular coordinates. Now, a lot of this stuff you've done before in other courses, so let's just make sure that we have the correct terminology for use in pre-calculus. So this lesson is 1.1 in your textbook and is on rectangular coordinates. So this has a formal name other than a coordinate plane. It's the Cartesian plane. There's a story behind the name, but Cartesian plane is a fancy word, or phrase, I should say, for coordinate plane. So the reason it's called a coordinate plane is because every point on here can be located by knowing the horizontal distance from the origin, x, which is our horizontal axis, and the vertical distance from the origin, which is our y-axis. So here we have 2 points, 1, 8 and 8, 3. And rather than going into how to plot points, which please let me know if you don't know how to do that, but we're going to go ahead and we're going to start on other things you can do. So one thing you can do on the coordinate plane is you can measure the distance between any 2 points. So because the point labeled 8, 3 and 1, 8 are some distance apart that we don't know what that distance is, we want to figure out what the distance is by using the distance formula. So the distance formula is just a form of the Pythagorean theorem. A squared plus b squared equals c squared, except remember the last step of the Pythagorean theorem is the square root plus the square root in the distance formula. So to figure out what the distance is between the 2 points, we go ahead and we subtract the x's, 8 and 1. It doesn't matter which one's the second point or the first point. We square that distance. Then we add to it the square of the difference in y's, 3 and 8. Then we simplify. 8 minus 1 is 7. Squared is 49. 3 minus 8, negative 5. Negative 5 squared is 25. We add those numbers together. 49 and 25 is going to make 74. And the only other thing we can do is try and see if we can factor out any perfect squares, which there are not. So the distance between those points would be the square root of 74. So another way on the coordinate plane that you can use the distance formula is by telling if a triangle is a right triangle or not. Well, there's a theorem that you learned in geometry that says if the 2 shortest sides squared if the 2 shortest sides squared and added together is equal to the length of the third side, then it's a right triangle. So let's see. Okay, so if I take these 2 points, so we're going to call that distance 1, and use the distance formula. I'm going to do a little magic and do it really fast. You pause and you work it out yourself. Okay. For D2, I'm going to be using these 2 points. And for D3, I'm going to be using these 2 points. So if I go ahead and graph those 3 points, I get this shape, which could be a right triangle, but I drew kind of that. Okay, so my first distance, D1, which is the square root of 5, is the distance between these 2 points. My second distance, which was from 2, 1 to 5, 7, is going to be this distance right here, which is 2, 3 square root of 5. And then I got the square root of 50, or 5 square root of 2, for that third distance. Okay, so then to see if it actually is a right triangle, once we know those distances, we can go ahead and use Pythagorean theorem. Square root of 5 squared plus 3 square root of 5 squared, is it equal to 5 square root of 2 squared? So we get 5 plus 45, is it equal to 50? And I square all those. And it is. So lo and behold, this is a right triangle. Suppose that we wanted to figure out what was the midpoint of one of those distances. So where would it be right in the middle? So if I was at 2, 1, and I was going all the way to 5, 7, and I said, okay, where's the middle exactly? Well, the midpoint formula just basically says that you can average the x's and average the y's to get the midpoint. So you go ahead and, remember we're doing 2, 1, and 5, 7. We add the x's, divide by 2, add the y's, divide by 2. 2 and 5 is 7, 7 divided by 2, 3.5. I am using decimals, and let's put them on the coordinate plane. 0 plus 7 is 7, 7 divided by 2 is also 3.5. So if I go to 3.5, 3.5, here's 3.5, about right there will be the midpoint. Okay, so a little bit of a switch up, but now we're just going to extend our knowledge of the coordinate plane, and we're going to review graphing equations. So just as a reminder, a table of values is always your friend. We want to go ahead and we want to graph any equation. Remember, our x is our inputs, y is our output. And so if I go ahead and I say, what is the value of y when x is -1, 0, and 1, I get -5 minus 3, 5 times 0 minus 3, 1 times 5 minus 3. And hopefully you remember there's lots of shortcuts for doing this. So you could do it a way that you already know how to do. After I've graphed the points, I can then go ahead and graph my line. Okay, and as a reminder, this point where the graph is crossing the y-axis is called the y-intercept. And this point where the graph crosses the x-axis is called the x-intercept. Just as a reminder, a y-intercept is also defined as the value of y when x is 0, and the x-intercept is the value of x when y is 0. Okay, so let's look at this function, and this time we're just going to go ahead and look at it from the lens of a table of values. So if I go ahead and I put in a -2 for x, I get 5. If I put in a 0 for x, I get 1. If I put in a 2 for x, I get +5 also. So let's graph those. So this shape is known as a parabola. It has some symmetry. So symmetry is vertical. This point, remember, is called the vertex. There is no x-intercept, but there is a y-intercept that happens to be at the vertex. So let's go as a reminder how to find the x and y-intercepts algebraically. So if you're finding the x-intercepts, you're going to substitute a 0 for the y. So to find the x-intercept algebraically in this equation, I would take the y value, replace it with a 0, and I'm going to go ahead and I'm going to solve this by factoring. And if we need more help with this, I will help you. But for this one, we have a common factor, x. And when I take it out, I'm left with 3x minus 2. And hopefully you remember that you take each of those and set them equal to 0. So x equals 0. 3x minus 2 equals 0, giving us x is 2/3. So I have an x-intercept at 0 and an x-intercept at 2/3. To find the y-intercept, I substitute a 0 for the x. Y equals 3 times 0 squared minus 2 times 0. 3 times 0 squared is 0. 2 times 0 is 0. 0 take away 0 is So the y-intercept is at 0, and it has two x-intercepts, one at 0 and 2/3. It is quadratic because that's the second power, which means it's a parabola. And on the x-axis, those 2 points are going to be at 0, 0, and 2/3 0. Thank you.